The agenda is quite packed today. We're going to start talking about why care about esoteric command and control. Why is it relevant to you in the banking industry? How is it relevant to your segregated environments, Swift? Perhaps you've got critical national infrastructure environments. Why care? And Alfie will be talking about that from a blue and red team perspective. We'll also briefly introduce the tool that F-Secure developed for esoteric command and control, so C3. The meat of the talk will be talking about 4 different techniques that we've developed for weird and wonderful ways to establish command and control out of segregated networks. So the first is VMware, so specifically using VMware tools and the Vcenter API to establish command and control into a VM that you have no network access to. Using network printers to exchange arbitrary data for command and control. Using RDP map drives for, again, command and control, funnily enough. And lastly, my personal favorite, using LDAP attributes, so Active Directory account attributes, to transfer that data as well. And lastly, we'll give you some takeaway points as well.
So, yeah, I think as James said, pretty bluntly, why care? So from a defensive standpoint, I guess practically we should always be challenging our assumptions about how users interact with our network, how data moves across our network, and of course, in this case, is how attackers may use that to their advantage. And I think it's fair to say that tradecraft like this is increasing in popularity, maybe arguably less so from an internal kind of peer-to-peer C2, but certainly kind of internet-bound traffic, the likes of Dropbox, Google Drive, Slack. You've seen countless examples of threat actors using those to great effect. So this same principle, I think, is only going to increase in prevalence as we move forward. From a red team or an attacker perspective, an offensive perspective, bypassing network segregation is kind of bread and butter of Tim's job, right? So understanding those defenses and maybe the shared services that might actually kind of act as a bridge between various network zones, be that untrusted and trusted, be that corporate network, an OT network, understanding those and overcoming those is part and parcel of offensive engagements for us. And then evading detection is just a byproduct of that. Taking a path less traveled. Likelihood is that from a SOC's perspective, they're going to be focusing on the WinRM, the SMB name pipe type stuff that is probably more prevalent that we see across every network ever. This kind of stuff is something that might not be as heavily scrutinized, and as such, you might have more joy using it in an offensive kind of scenario. So as James mentioned, C3 then, so custom command and control. The idea behind this and the reason we developed this and saw a need for this is pretty much for all the reasons I've kind of covered when it comes to network segregation, overcoming these things and doing it in a way that is both maybe novel and overcomes defenses, but equally is in a kind of maintainable and actually actionable way. If we develop some super crazy stuff that can only be used in a very specific circumstance and doesn't really integrate with any other tooling, probably not going to get used, and probably the cost benefit for us is low. And indeed, for those trying to simulate this for their own clients across their own red team engagements, the likelihood is that our clients aren't going to see the impact of this and see the artifacts this produces and not build defenses accordingly. So that's why it exists. We released this with 2019, I think, and there's been huge input from the community in terms of developing new channels for this. There's everything there from as James has already said, and you'll see today, using kind of shared folders, Active Directory, printers even. And as of this week, we've added 3 more, including community submissions there for Jira, Mattermost, and Discord as well, highlighting specifically in this case the kind of internet-bound channels, what's possible there, but there's obviously many more, and you can use your imagination, which hopefully when you take this away, you'll kind of have that mindset of what could and could not be a C2 channel. How C3 works when in its implementation. On the left-hand side, we have C3. This is the attacker-controlled infrastructure. On the right-hand side, we have a target host that's going to be executing the implant. In C3 terminology, that's a relay. We heard about Cobalt Strike's beacons, same kind of principle. So in the middle of our attacker-controlled infrastructure and our target, we have an arbitrary C2 medium, and I mean arbitrary. Hopefully from the channels you saw, you can get some idea of how arbitrary this really is. But what's going to happen is, on the right-hand side, we launch our implant, our relay. This is going to write a packet or a message in whichever medium makes sense, and that is going to be read and likely deleted just for housekeeping, I guess, by C3, and that can respond in exactly the same way, writing its message to the C2 medium, and then that can be received on the other side. And over this medium, and I think this is where it really, if you kind of pay attention to offensive security and you maybe understand the tooling and the tradecraft that exists there, it ties into being able to launch a Cobalt Strike beacon using its external C2 framework. So that means that from what was just this relay that we've executed, we can stage and upload a Cobalt Strike beacon all through this arbitrary medium. So that medium could be your Dropbox channel, that could be over LDAP, use your imagination as to what that is, but that's the premise. What we're talking about today and the subject of James and I's research is how do we interface with this medium? How do we send messages over this medium? And then C3 takes all of the stuff away when it comes to chunking up the traffic, encrypting that traffic, and managing the connection back to Cobalt Strike. So all we're doing is the communications medium, effectively. I say all we're doing, it's a pretty big deal. So
I like to think.
what do we need? Yeah, what do we need then for C2? And this varies to some degree, but effectively you need to be able to read and write, of course, for any C2 that is interactive in nature. So rather than just beaconing to say I've run a thing, something that's actually going to be tasked with further commands and be useful operationally on red teams, we need to be able to read and write. And optionally, we need to be able to list and delete the files or messages that exist in that medium. In some cases, that's not relevant. But in some cases, it's taking Dropbox as an example. We need to list the files that are present in a Dropbox folder to be able to decide what's for us and delete the ones that are for us once we've read them. So that's the idea. And if you have those things, in principle, you have C2. You have the ability to write an arbitrary, kind of C2 channel here. Some things worth mentioning here if you're going to go down this path around, if you're using a web-based C2 channel, the likelihood is you might run into things like API rate limiting. So if you're building a channel here, you kind of factor those things into say just how useful is this. And further to that, I guess, is if you're reading and writing messages, some mediums will restrict the quantity of data that you can send over that channel in any one message. So some channels are possible, some channels aren't really viable, but the premise of achieving C2 over them is still valid. So I'll pass back to James then for operationalizing some of these.
Yeah. So into the meat of the talk, I guess. I'd encourage you as we go through this to think about what is going in and out of your segregated networks, so your Swift environments, your operational technology networks, these sorts of things, and just see whether you can think about read, write, and delete, how that applies to your own environments. So first one is VMware. So this is the biggest channel we're going to talk about. We're probably going to spend 10, 15 minutes because it's the most complicated from a technical perspective. Just a bit of background what VMware is. I think it's something crazy like 99% of Fortune 500 companies have VMware somewhere in their environment, so chances are you probably do as well. You've got ESXi, which is the thing that's actually running on the bare metal, right? So these are your rack servers in your data center, they're running ESXi. Then you've got Vcenter, which is the brains, and that's what connects up all the ESXi servers and manages the virtual machines that are running on ESXi. And it's Vcenter that we're going to be hooking into the API of, and that's going to be interacting with the virtual machines running on ESXi and VMware tools that's running on those virtual machines. So let's think about a scenario you might find yourself in as an attacker. You've compromised workstation 1, and you want to get access to, let's say, workstation 2. You've got no direct network connectivity because there's a firewall, but you have been able to compromise credentials that get you access to Vcenter, which manages the virtual machine that you're trying to get into. What we can do is abuse Vcenter's API because it exposes a whole bunch of functions that allows upload, download, arbitrary code execution, all of these kind of really interesting things to interact with the guest OS without any network adapters at all. So it could be a completely isolated machine, but we use VMware tools to control that machine, basically. To help facilitate this, I've developed a tool called SharpSphere. It's a .NET. You can run it through a beacon if you're an operator, and it basically sits in front of the Vcenter API and allows you to do those interesting things in a much more user-friendly way, right? So code execution, file upload, download, listing of VMs, and also we're not going to cover this in this talk, but there's some research that I have published about dumping memory of running VMs. So you can take a snapshot of a VM's memory space, take credentials out of LSAS, do all sorts of interesting stuff with that. So let's look at this from a data flow perspective then. We've got workstation 1 on the left-hand side. This is where we've initially got our foothold. Workstation 2 is where we're going to be executing our relay, so our, the F-Secure's beacon, the actual payload itself. And we've chosen an arbitrary directory on each side, C users public. It can be anything as long as both sides can read and write to their own folder. SharpSphere will be running in the background, talking to Vcenter's API and making things happen on Workstation 2, essentially. So what would happen is you use SharpSphere to upload your payload, you use SharpSphere to execute it, and then you run SharpSphere continually in the background to mirror these two directories. So C users public on both sides. What this looks like in practice is you execute your relay on Workstation 2 in the top right-hand corner. That's going to write a packet to its own C users public folder. Right, so there's an actual file in C users public on Workstation 2 right now. SharpSphere will take that, move it across to Workstation 1, see through, pick it up, interpret it, do what it needs to do, put its response back onto C users public, where SharpSphere will upload it using the API to Workstation 2, where it's received. So that's how we get that two-way data transfer. So that's essentially command and control established. There's a few limitations, like if you're an operator to consider. You do need valid credentials, obviously, for Vcenter. This isn't an exploit. You're just abusing the API. So you need a bunch of guest operations privileges, not necessarily an admin. You also do need different valid credentials for the guest operating system as well. So if you could reasonably sit down in front of it and log in, you can probably use those credentials. So it doesn't need to be an admin necessarily, just something that can log in. And obviously, also, the guest OS needs VMware tools installed. So the basic workflow, you find a Vcenter server, create a channel in C3, you use SharpSphere to upload your payload, you use SharpSphere to execute the relay, and then lastly, you use SharpSphere to sit in the background in C2 mode, which you'll see in a minute, to mirror those two directories and get that file transfer running seamlessly. In our experience, you can typically find Vcenter using LDAP. So the operating system service pack will be unknown. You can use that to filter results. Looking for things like VCSA, Vcenter, ESX, all of these sorts of things. Or just look in information repositories like Wikipedia, Wiki, rather, internal Wiki, SharePoint, that type of stuff. So we've got some videos to demo these. So this is SharpSphere running through Cobalt Strike on the left-hand side, and C3 is on the right-hand side. Got an aggressor script to make it a bit more user-friendly. So all we're doing here is using SharpSphere to list the virtual machines that Vcenter server is managing. And you get a full list of all the machines and whether VMware Tools is on there, etc. So as an attacker, you can find a Vcenter, pop it, see what VMs are on there, and then try and interact with them. We see Workstation 2, so for the demo, this is what we're going to do. And we're just going to take a note of the IP address, because that's how we're going to reference it going forward. I kind of cut out a lot of the middle steps to go to the money shot. So this is where we're actually established the command and control. So again, at this point, we've already used SharpSphere to upload the payload, the relay, and execute it. So it's running there on Workstation 2. We just need SharpSphere to run in C2 mode to mirror the directories to get the data transfer. And so there's a whole bunch of things. It's pretty straightforward, but you see the local and guest file directories. That was just C users public on both sides. So that's the directories that it's going to mirror. All being well, you see on the right-hand side, it's checked in to C3's GUI. So at this point, we've got the command and control, right? There's two-way data transfer because C3 has taken care of all the chunking and all the message tracking, etc. As an operator, we want a seamless user experience, so we can add our beacon through that relay. And if you were looking at C users public on both of those places, you'd see the files appear very temporarily. They get deleted as soon as they're read by the other side, right? So we set that off, and we can see that Workstation 2 is checked in, and from an operator perspective, we can just begin doing our operations as we would with any other internal C2 channel.
Cool. So as James said, this is arguably the most convoluted channel. There's a lot of moving parts here, and as such, there's a fair selection of detection opportunities. I won't go into all of them right now. There's a link, I think, in a minute for the slides from the Black Hat talk we did for this, and you can look at all of those in depth if you need to. So we're just going to cherry pick some of these. Firstly, C3 usage. This goes for obviously this channel and all subsequent channels, but C3 itself has its own artifacts that we can detect upon. Here we go. This YARA rule here is from a FireWire blog from the dark side ransomware usage, and we can see a series of strings there that we can scan for to identify C3 binaries. And then on the right-hand side is another YARA rule that will look for reflective shellcode injection, and specifically the exported function there, which has a name, start node relay. And if we scan, in this case, you can see I've basically taken a memory dump of Internet Explorer, and we can identify here that a C3 relay has been injected into Internet Explorer quite reliably there. So if they're using either shellcode or binaries on disk, we have options there that we could use to detect it. .NET tooling, so obviously James's SharpSphere tool is essential to this C2 actually taking place. And indeed, its constant running in memory needs to happen for the C2 communications to happen. The guys earlier were talking about the kind of post-exploitation capabilities of Cobalt Strike. We can use this through Cobalt Strike, as we saw. And then we have options here to detect it using either YARA rules. So on the left-hand side here, you can see an option to detect the strings in SharpSphere and detect that, and you can see the example there. And we also have some of the ETW fiends that James alluded to as well this morning. So we can see there SharpSphere is being loaded specifically into run DLL as my spawn 2, again, which we heard about. API usage log. So this is a bit of a different one. So rather than focusing on endpoint activity, what we can do is look at the vpxd.log on the vCenter server. Here, you can see the beaconing behavior taking place. So as James mentioned, we're finding by IP address. So we have the IP of our target virtual machine. We can then initiate a file transfer. So there is a file on the guest that we want. So we initiate the file transfer to download it. We delete that file to clean up the folder. And then we continue to list files, waiting for new messages to be digested. And then that process can repeat itself as we send communications to and fro. From a preventative standpoint, I think the most fundamental one here is to restrict access to vCenter for normal users, of course. So there's a few ways to go about that, both in terms of principal or least privilege who can actually log in and authenticate, both to vCenter and to the API. But also, if you're using some form of privileged access workstation, then actually having no network visibility of vCenter kind of solves at least some portion of that as well. You can also restrict the use of guest operations API methods, and you can use VMware tools selectively. So it does give you the option of installing just the quality of life features that you want, rather than necessarily the things that facilitate file upload and command execution. So that, again, is essential for this C2 channel and would effectively be mitigated by this. So we move on to the second channel, printers.
Yeah, brilliant. This one's a lot easier. My personal favorite was, I guess LDAP's probably my favorite, but this is fun, I guess. I've never seen it used in real life. We've never used it. So if you do use it on an operation, please let me know. Basically, you'll know that you have network printers that you should be able to connect to and submit print jobs to. Well, what you can do is, because for some reason a print job name allows 1 megabyte of data to be stored in it, you can submit a print job with C3's data stored in the print name. And you can use the print queue as your C2 medium. So it's quite basic, but fun. So workstation 1, workstation 2, they can't talk to each other, but they can talk to the same network printer. So from a data flow perspective, very, very simple, right? You've got workstation 2 executes its relay. That's going to create a print job, which you see in the top right-hand side. So that is just C3's raw data that's been encrypted and in base 64 encoded. So real suspicious if you're actually looking for it. So it's going to write the print job. Workstation 2 is going to read that job because it's continually looking at the print queue. Delete it, obviously write this print job, and then the other side reads it. So that's the two-way data transfer. Again, there's a few limitations. You obviously need to be able to access the same printer. And also, because you are deleting jobs, you need to ideally be running both sides of the channel under the same user context. Or at least one side needs to be an admin, so that you've actually got the privileges to delete jobs that you don't necessarily own. You'll also see that I wrote the channel to support unlimited print jobs, right? So you could end up with like hundreds of them. Operationally, it's been not as stable for us, so I would recommend just limiting it to 1 print job. Because you can have 1 meg in each print job, it's still fine, fast enough. Much simplified workflow when compared to the VMware one. You just find a printer, create a channel, job done. From finding printers, again, LDAP can be your friend. So if you're running for a beacon, Alfie wrote an LDAP BOF that allows you to do LDAP queries. So you can find network printers. You can also use PowerShell WMIC, etc. I'm sure you won't have any trouble finding a printer. Yeah, so create a channel. You see, I'm not sure if this is a video. No, it's not. So on the right-hand side is C3. There's a specific channel type called channel print. You can leave everything as default except the outbound job limit and the printer address. They're both pretty self-explanatory. So again, we'll skip to the interesting part. We assume for the demo that you've got some out-of-band way of executing the relay on the target. We've RDP'd to it, but you might have an SQL breakout. You might have whatever you've got of executing your code on workstation 2. And if you keep an eye on, in a second, when we actually stage the beacon through the thing that's just checked in, you'll see the print jobs are created and then destroyed on the bottom left-hand side. So you can see the print queue, and then all being well, I should note as well, the jobs are stored, they're created rather in a paused state, and they're also invalid print jobs, so they're never going to start shooting out paper at a client site or anything like that. They're invalid, they'll never work. Yeah, so you can see the beacon is checked in on the right-hand side in C3, and then it's also in Cobalt Strike. So operator experience seamless from that point on.
Nice, thank you. So detection opportunities then, obviously slightly more simplified in terms of workflow. So we still have a handful of things we can look at, so we're going to dive into a few of those. So Endpoint Ui. So if you're running this channel in the context of a user, and there's any issues with the printer that you're targeting, very helpfully, the Windows endpoint could notify the user that there's low ink, there's a jam, anything like that. And that could obviously show up, and if they're so inclined, they could investigate that, and that could give you a bad time as an operator. You can disable those notifications using changes to the registry, but that obviously has its own implications for operational security. Probably the most useful, and I think James kind of termed it well, it's pretty simple when you're looking for it, which is in the print logs here, we can enable logging of the job name. So we end up with 308 and 310 event IDs here, and you can see quite clearly on the right-hand side the alphanumeric text, which is the C3 message in action, basically being logged there. And as James said, you'll see them in a pause state, and you'll see them being deleted again as the data transfer is taking place. Third channel RDP.
Yep. We're overrunning already, and I'm keeping you from the alcohol. Yeah. So we're going to go through this a bit quicker. Remote desktop, we should all know what that is. It's for remote administration of machines. There's a function of it that allows shared drives, right? So you expose an SMB or UNC SMB, but via the UNC share name over the remote desktop connection. Data flow, execute the relay on workstation 2. You write a packet to C users public. That's an arbitrary folder. From workstation 2's perspective, the key thing is you're referencing it via the TS client UNC name. So you are writing the data straight to workstation 1, but you're using the remote desktop session to actually expose that folder to workstation 2. And then everything else from that point is the same. That's how you get the two-way data transfer. Obviously, map drives must be permitted. It is by default, but if you're operating in a really restrictive environment, it might be disabled explicitly via GPO. For RDP execution, if you're doing this via a beacon, like you would on an actual red team, you're probably using sharp RDP to do the remote desktop session through a beacon. If you are, the keyboard of the target must be US English, just due to the way it's doing the keyboard mapping, and also you can't have special characters. So when C3 generates a relay, it's got underscores in it, so you just need to change the name. I'm sure you would anyway, but if you're doing it via the MSTSC actual client, like sitting in front of a computer, you don't need to worry about that. Yeah, workflow, yeah. Create channel, yeah, so workstation 1, when you create a channel, you're referencing workstation 1's directory, C users public, so that's what you do there. When you're doing it, when you're creating the relay off that channel for workstation 2, you're just referencing TS client, C users public. Pretty easy. Yeah, I'll show you this one actually because it's interesting. So you're using sharp RDP here to execute a relay that you're also hosting on that drive that you're mapping across. So you never actually need to upload a payload to disk on the other side. You just create your remote desktop session, connect the drive. Key flag that I've added in the pull request is the exit equals false. And that's going to keep that RDP session open all the time. So it's going to execute it. The RDP session, so sharp RDP is still running as a job through Cobalt Strike. and it's checked in there, so you can then go ahead and stage your beacon.
Firstly, I think just to clarify, just in case it wasn't clear before, is that if we have our relay running in whichever fashion we've managed to achieve code execution, when we launch a Cobalt Strike beacon, as you saw there, adding the peripheral beacon, what is happening is that beacon is running within the same process context. So it's not spawning anything else. It's all within that relay process. But what does happen when we run Sharp RDP or any other .NET post-exploitation tooling is we do spawn a run-to process, spawn-to process, as we saw this morning. In this case, that could be, most commonly, in fact, run DLL32. And that is the process that is making the network connection across the network to the target host on the RDP port there. So what that means is, well, firstly, we're using .NET tooling. Sharp RDP needs to run, certainly in our scenario at least, needs to be running to establish that RDP connection. And as such, we have opportunities to look for it there. So you can see at the very top there, Sharp RDP is one of the loaded assemblies. At the bottom there, you can see this AX interop. That is the ActiveX client DLL used for RDP to actually initiate the connection, gives the functionality to initiate the connection. So we can see that loaded DLL. And of course, probably arguably most suspicious, we can see that RunDLL is making this network connection to a host over 3389. So we have more to work with there. Prevention, if this is a Bastion host and this should be treated as such, then things like map drives, things like copy and paste can be disabled or certainly restricted in terms of GPO, as James said, on the server side. So that just kind of mitigates this entire issue when it comes to map drives, certainly. And the other one, which is, I guess, more of a broader thing, is around application control. So if you're using device guard, if you're using Windows Defend application control, those kind of things allow you to effectively reduce the likelihood of being able to execute arbitrary code on the Bastion host in the first place, which kind of takes this idea of us just uploading a relay exe and just running it, kind of makes that slightly more challenging and obviously adds to what is already rather esoteric. Last channel, LDAP.
Yeah,
best till last.
Yeah, my personal favorite. Just mainly because almost every environment's got Active Directory in it, right? So if you land, any user can use this channel. You need no additional privileges. So it's quite, and we have used this one operationally, and it's never been caught, I don't think, unless things have changed over the last few months. So LDAP is what underpins Active Directory, essentially. And every user has the ability to modify certain attributes of their own account without any extra privileges. And we can use those attributes to store data. And that's how it does the data transfer between two endpoints. So again, the scenario, workstations don't have any network connectivity with each other, but they can talk to the same domain controller. And so that's how you can bridge those network boundaries if you're in the same domain or forest. So data flow is a bit complicated, but there's a concept of a lock attribute and a data attribute for this channel. The lock attribute simply tells the other side who the message stored in the data attribute is destined for. So in this case, we would write some unique identifier for workstation 2 into the lock attribute, and then we'd write our message into the data attribute. And if you looked in Active Directory, like AD users and computers, and you looked at this user, you'd see C3's data in that user's attribute. Workstation 2 is continually doing LDAP queries, looking for new data in those attributes. It sees it, or it checks the lock attribute. Is it destined for me? Yes. Read it, clear it, both attributes, and then that's how it's doing that two-way data transfer. Both sides need to communicate with the same domain controller, and both sides need to be able to modify the same user's attributes, right? Because you need to be able to hard code in each side which user's attributes you're changing. And also, if you stray from the defaults that we've configured, you need to be cognizant of the size and the data type of the LDAP attribute itself, because it can change. You'll see in a minute, but you just need to be aware of it. So when you're creating the channel, this is probably the most difficult one to set up. We choose some sensible defaults. So MSMQ signed certificates is the largest attribute that you can modify as an unprivileged user. So it's about 1 megabyte, I think. And the max packet size represents that. So if you change those, you need to be looking at documentation and stuff. Username and password, yeah, it's fine. Again, straight to the money shot. I will show you this one because it is interesting. You are executing the relay through your, again, some out-of-band channel. Use your imagination on how you'd be executing that. But behind the scenes, that is writing data to Active Directory, right, using LDAP. And Workstation 1 is continually looking at those attributes. So there's not much to look at on this video, I guess, but you'd be able to see it in LDAP if you were looking.
So section opportunity here then. So we've got a few. We've got endpoint focus, the network connections to the domain controller to query for messages and change attributes, and the events that service from the domain controller in question. So LDAP queries first then. We can use something like an ETW feed for this from the endpoint. So you can see here there's our lock attribute and our data attribute. So we're querying the international ISDN number, and then we're querying the MSMQ sign certificates to see the data that's destined for us. If we query the first one and find out that there isn't anything for us, then we'll continue to poll that rather than going for MSMQ as well. So we're just waiting for something that's our problem, effectively. We've got a couple of options from event log side. So we've got directory service access events and directory service change events. So the changes here are 5136. The access events are 4662s, and this needs an SACL applied to the attribute to actually surface the event. But what you can see when you do that here is us changing. So the ISDN number attribute is being changed. And plainly here, you can see that the attribute, that alphanumeric code there is the lock attribute. That is effectively the address, the destination for our message. And so that's basically it. So was there another slide? Who knows? Conclusions then. So I think what you've seen is, I'd probably say, like a spectrum of the esoteric channels that you can do across the corporate network using some of the shared services we see most commonly. I think the main message really is it's probably, I guess, a showcase of how something like C3 and similar frameworks allow you to take what would arguably be a channel that's not worth the time developing and get it in the hands of operators, in a reasonable and kind of sustainable way. But I'd like to think that it will challenge you to look at the network boundaries and the trust boundaries between your various networks and say, if we've got shared Active Directory infrastructure across our network zones, then maybe that's something that needs to be addressed. Equally, if you've got shared services internally as well, like we obviously see in printers and the like, but consider something like Jira or Bitbucket. If that's shared between corporate and production, you can definitely use that to pivot between. That's something that we've done as well. So ultimately, once you've looked at that and decided everything's on fire, from there, it's a case of mitigation, prevention, detection. If there's, as we saw with the guest editions, with VMware tools, and actually just removing that capability from the endpoints we're using it on, if there's things there that can actually be used to just harden the network and the infrastructure, if that's removing map drives capability, all those kind of things we can do to just make it more difficult to even, for any of these channels to be possible. And hopefully some of the detection advice, both here and in the slides for Black Hat, will help you on that. And then also just general attack surface reduction methodology really here is, even if you start thinking about the external channels as well, we talked about the Dropbox and the Google Drives that we see from threat actors. If those aren't services that you consume in a corporate context, then they can be blocked at the proxy and just make it a little bit more difficult for attackers to just roll with that stuff that clearly gets them somewhere elsewhere. So hopefully, some cool stuff there, but also, some good action points for you to take away.